This is the first of a series of tutorials on importing Darwinex tick data into your trading applications. Those could be trading platforms, or they could be algorithmic trading strategies, code that you've written in various programming languages, etc. So the use cases are multiple here. In terms of prerequisites, you'll need to know, of course, how to download data from an FTP server, as all Darwinex tick data is housed on an FTP server. Programming experience, you'll need that to follow the contents of this presentation as we cover everything and create the solution in Python. To follow the content, you'll need to know some terminology. For example, what is spread, certain descriptive statistics such as mean, median, mode, etc. Simple stuff, nothing too complicated. So in terms of agenda, we'll go through firstly the file structure and contents of Darwinex tick data. Those of you who have access to it already are aware that it follows a slightly custom format and is available in compressed archives from Darwinex FTP servers. So we'll go through exactly how to acquire it, what to do with it, how to interpret it, and how to neatly put it into your environment and do things with it. We'll go ahead and standardize all the tick data we retrieve from the archives into one format that we can use in multiple places. For example, in importing data into MetaTrader for backtesting, or importing data into Strategy Quant, which is something we'll quickly demonstrate towards the end of this presentation. And in future tutorials, we'll go through in detail this importing Darwinex tick data as FXT files into MetaTrader for tick data backtesting, things like that. So we'll also briefly go through resampling and rebasing to OHLCV format. OHLC really, not volume, as volume is interpreted in terms of ticks as far as FX CFDs are concerned. And towards the end of this presentation, we'll just quickly go through what we're going to cover in future tutorials. So without further ado, let's begin. Let's first go through what the Darwinex tick data archives look like. So we'll just quickly have a little title here, Darwinex tick data, and inside each archive you'll find is compressed using gzip. Once you uncompress the file and look inside its contents, each file will, there are two types of files. You'll have a bid file with bid in the file name representing bid prices, and you'll have ask. Each of those will follow this format. You'll have a Unix timestamp, right? You have a Unix timestamp, and that will be in milliseconds, followed by a price. Now, depending on the file name, for instance, if it's bid, if the file name contains bid, then the price you're looking at is the bid price. And similarly for ask, it's an ask price. And the last variable here will be the size. Now, this is something you don't have to worry about right now. In future, when we go through certain tutorials on fixed API usage, we'll describe in more detail what bid size or ask size means in this context. So for the purposes of this tutorial, we can ignore the size. So that's essentially what each file looks like. You have each line containing this information. You have a timestamp, you have a price, and a size. Typically, this looks like, for example, 153 something something something, a millisecond timestamp ending in 12, for instance, and you have a price 1.41316. Completely random, I just made up right now, and you'll have something like this. So each line in the decompressed archive will look like this. Now, what do we do with these? So as with most tutorials in this series, we're going to jump straight into my Python environment and go through things via code. It's important to jump through the code and understand exactly what it's doing, so that in future, should you want to implement this in any other programming language or do it manually in Excel or other spreadsheet software, things like that, those options are open to you. As long as you understand how the process is structured, you can implement it in any programming language. Python, of course, makes it very easy to do and does it fast. So here we are with the first code segment. I've written this class for you, dwxtickdata.io. Inside this class, you'll find a few features. I'll leave the nitty-gritty details out of it so that you can go ahead and read through those in your own time. But the very first function, find symbol files, looks at the path you specify in the beginning and looks for files by date, hour, and symbol. Depending on what you specified, it filters out the files that are relevant to you. For instance, if you specify only the symbol, then it will go ahead and find all files available in that directory where you've downloaded your tick data. This is where I've downloaded my tick data from the Darwinex FTP server into a folder called DWX tick data. So you need to replace that with whatever your path is to where you've downloaded the tick data, the raw files, the compressed archives. And this function will essentially return those files in two lists. The first list will contain all bid files, and the second list will contain all ask files. And this isn't necessarily the way you should do it. This is what I've done for this implementation, as you'll find out shortly why I've done that. But there's absolutely nothing stopping you from just reading all the files in one go and doing it some other way, using some other logic. The next function is a little function, construct data, which essentially does two things. We know that each archive is compressed via gzip. So the first thing we want to do is uncompress or open the compressed archive, and inside that, wherever the file there is inside it, we need to read it line by line and make sure that we're skipping any empty lines, decode the string, strip it, split it by the delimiter, which is the comma. It's a comma separated value file that you'll find inside the compressed archive. And that's it. You create a data frame out of it. And once you have that data frame, we do a little bit of checking. The first check is, did the file name contain bid in it? In that case, create columns for this data frame as bid price and bid size, and ask price and ask size in the case of ask being in the file name. And that's it. And you set the index, the timestamp, which is a millisecond Unix timestamp, apply a numeric conversion to the values in the data frame, and return it. Very simple. Now, get symbol as data frame is just one function that achieves pulling all the file names, creating a massive data frame out of them, and doing some post-processing on them, such as, for instance, if you don't want tick data, you'd rather have OHLC data, open, high, low, close. Those sorts of things are provided inside this function. You can modify it to suit your purposes. You can use it as is. You can integrate it into the other scripts we've written in the past that download tick data from the Darwinex FTP server into your Python environment. You can do absolutely anything with it. So there's no compulsion on how to use this. This essentially shows you what the process is doing. So the first thing we do, we create our bid and ask file lists. We pull them from the function we wrote earlier, find symbol files. The next thing we do is we concatenate each data frame returned for each file into one big bids data frame. We do the same thing for asks, and then we merge them, do an outer join, merge the asks and the bids. We fill any and nan characters with a forward fill. I want to explain this in a bit more detail, why forward fill in this case. When you're receiving bids and asks from the server that's sending this information, when at the time these are being stored in the compressed archives that you're opening here through this implementation, bids and asks aren't necessarily received in the same order at the same time, sorry. So let's go back to the drawing board for a second so I can explain this. So prices generally don't follow one particular tuple format. So you're not going to get an ask and a bid price each time there's an update on the server at a market level. So for instance, you might have a timestamp, let's call that T1, at which you received an ask price. Let's first make this little table here. So we've got an ask price and a bid price, and we've got a few timestamps, T1, T2, T3, so on and so forth. So each time prices are received, they aren't necessarily received as a tuple, meaning ask and bid aren't necessarily supplied together each time there's an update at each tick. So for instance, let's assume the first ask was 1.50010 and the bid was 1.50011. So we have a spread here of 1 point. Now, the next tick might not necessarily contain both ask and bid updates. You might get a new ask price. So you might get a 50015, and you might not have any bid price returned for that tick. So what we're trying to achieve here is we need to do the forward fill, because if a new bid price is not available for that timestamp, it implies that the previous bid still holds. So when you're constructing the data frame, if there has been at this timestamp an update to the ask price, but no corresponding update to the bid price, you assume that the previous bid price holds. And then in the next one, for instance, if we had an update to the bid price of 1.50051, we had no update to the ask price in that timestamp, then we assume that our price remains 50015. So that's the reason we need to do the fill NA implementation as we showed you earlier, because when you receive a NaN, well, when you're going to construct a data frame, you're going to have a NaN in a situation, not a number, where the ask price wasn't found for that timestamp. So because the ask price wasn't found, you must infer that no ask price was published for that timestamp, and therefore the most recent prior to this timestamp ask price holds, and the same goes for bid. And of course, all of this hinges on one major assumption, that your timestamps are ordered chronologically, smallest to largest. Since they're millisecond Unix timestamps, you need to make absolutely sure the very first thing you've checked is that your timestamps are ordered and that you're not missing data in key places. Because what will happen with a forward fill, a fill NA of this nature, is that you might, for instance, be missing timestamps for an entire day or an entire month, for instance. If you go ahead and do a fill NA on that sort of time series that's corrupted, or, well, perhaps legitimately missing that data, but if you do a blatant forward fill of this nature, you're going to end up with possibly a very strange looking time series, because you might have a jump of thousands of pips that A, didn't happen in the real market, and B, would completely mess up your data. So fill NA with a forward fill hinges on the assumption that your timestamps are A, ordered, and B, not missing data. So make sure you do those checks prior to using this sort of functionality on tick data. So jumping back into the code, we went through the bits where bid and ask files. We retrieved those. We created data frames, a massive data frame for bids and asks for all the files that were found. We merged them into one data frame, and that's pretty much it. Now your data frame is ready. We've conducted the fill NA method with ffill and dropped NAs here. So any data that had been left over with NANs, which is usually going to be right at the end, right at the beginning of the file. Now that we've done a forward fill, there won't be any NAs towards the end of the file. But if there were any, for instance, an ask was published, but a bid wasn't towards the beginning of the file, that wouldn't have been filled forward, and therefore we can drop those for our purposes in this tutorial. The next thing, you have some code here to go ahead and calculate spread. If you've set calc spread in the header variables to true, the arguments there, then it will calculate that spread and attach that as another column in this data frame. By default, the timestamps that you'll be reading from Darwinex compressed archives, tick data archives, will be Unix timestamps, millisecond timestamps. If you wish to convert those into more human readable dates, then simply run a pandas2datetime on the index of this data frame, which is currently in milliseconds, and convert that into human readable dates. You will need those for later applications, for instance, uploading data, importing data to different software. Strategy Quant, for instance, does accept timestamps, but for that purpose, we'll convert them to epochs anyway. Reindex to selected columns. Now, the data you've read contains ask price, bid price, ask size, bid size. Now, here you have the opportunity to tell Python, would you like to reindex data such that you only retain the variables that you're interested in. So in our case, we're only interested in the ask price and the bid price. However, if you wanted to include the ask size, bid size, and spread, then you could have simply avoided reindexing altogether and just taken the whole data frame out. So for now, we've specified under reindex that we want ask price and bid price, and that's what will be returned. The next part of the code is related to precision. So by default, the tick precision is what we're after for our purposes right now for this tutorial, but you may want to create an OHLC series out of the data you have and not necessarily want tick data. So as the output, of course. So if the precision is not equal to tick, then what we're going to do here is first calculate the mid price, which is the ask price plus the bid price, divide that by 2, normalize it, round it off by the symbol digits, which in our case are 5 for euro dollar, which is what we'll test on shortly. And again, you can specify different symbol digits depending on the asset you're working with. Could be an index, could be a dollar pair, yen pair, etc., all with variable symbol digits. And that's pretty much it. For the final bit that I'd like to talk about here is checking the integrity of the data. This is something we discussed earlier when we were on the drawing board, that it's very important to make sure that your data is not corrupted or is not missing data in key places. So there are a few integrity checks you can do after having created this data frame, or you could do some data cleansing prior to doing any of this. But let's say you've gone ahead and simply grabbed all the data from the Darwinex FTP server, run this script on it or any variation of this script on it, and you've now got a data frame. There are a few checks you can immediately do to ascertain whether your data is sane. It makes sense. And of course, feel free to add any more that you think are necessary here. So the first test is to just describe the data frequency, take a look at all the various values and make sure everything makes sense. The next one is going to calculate the mode of the gap distribution. By doing this, you can immediately ascertain what kind of frequency you can infer that your data is in. So in our case, if it's tick data, the frequency should make sense. So when we go ahead and execute all of this shortly, then in fact, I should really do that now because it will take a few minutes. So we know the script is already loaded, so the first thing we need to do here is create ourselves the object, which is dwx-tick-data.io. There we go. And now we're going to take a small subset of data from February 2019. Since time is short on a video, we don't want to spend too much time simply parsing data here, so we go ahead and say _io _get symbol data frame. And here we're going to specify a few things. So I'd like my symbol to be the euro dollar, which is the default, but adding it in here for completeness. The next thing I want to specify is the date. And remember that this date argument isn't strict, so it's more of a regex. You can enter parts of the date that should match in the file names that you're looking for, and that should be enough. So in my case, I'm entering February 2019, and February 2019 is the data I'd like. I'd like to convert the timestamps to human readable dates. So I'll set convert epochs to true. And I would also like to run an integrity check, which executes the 3 tests that I showed you earlier, checking for the mode of the gap distribution, displaying some frequency, descriptive statistics on the frequency, and the average spread per hour, UTC. So we'll set check integrity to true. In order for check integrity to work in this code, you need the data frame to have ask price, a bid price, and spread. So what we're going to do here is calc spread should be true, and we won't reindex the data, because if we reindex with the default arguments, it will skip over spread. So what we'll do is we'll specify a custom set of column names that we want. We want ask price, in our case ask price, then we want bid price, and finally we want spread to be output in the reindexed data frame as well. And that's pretty much it. The precision by default is tick, so we'll keep it that way, because one of the objectives here is A, to visualize what the tick data looks like, and B, towards the end of this tutorial, we'll be importing Darwinex tick data into Strategy Quant as an example of how to go ahead and use the tick data you've post-processed. And that's it. So we'll send this away for getting those files. Now, the first thing it's doing is what I described earlier in the first function. The first function is find symbol file. So it goes into the main path that you specified. In my case, it was e:, dwx tick data. It finds all the bid files, finds all the ask files, constructs data frames, merges by timestamp, and outputs one final data frame that has the columns that I've specified in the function reindex argument, which is our ask price, bid price, and spread. In the function, I've also set check integrity to true. So once it's calculated, once it's formed the data frame, it will run those summary statistics and other gap distribution studies on it, which is very simply, you're going to, here we go. And that's it. So we've got the summary statistics printed out. We've got the motor gap distribution. We've got the average spread by hour chart for the instrument. So these are just 3 tests that were put into this integrity check function just to quickly do something on this tutorial. Please feel free to add any more. And if you have some interesting tests that you'd like us to include in this script on GitHub, feel free to send those in, start an issue, or send us an email at info@darwinex.com, making us aware of them, and we'll add them and reference you in the code as well. So having done this, let's now move on back to the remainder of this presentation. So we've gone through the file structure and the contents. We described how to interpret what we see in each raw file, how to standardize it to one format using the function provided in the Python script. Resampling and rebasing to OHLC data is possible within that same function. The precision parameter we used was tick because the next part of this presentation involves tick data, but you can, of course, provide any other precision that is a compatible precision with Panda's resampling rules. So if you provide a precision, for example, 24H or any other compatible rule in Panda's resampling, the data will be resampled and OHLC'd using that precision. The next part of this tutorial is going to cover a brief demonstration of how to take this data and upload it or import it into StrategyQuantX, the data manager component. So the first thing I need to do now is to convert the data frame I have into a CSV file for use with trading applications. In our case, the first trading application we're going to talk about here is Strategy Quant. And inside Strategy Quant, we have the data manager where we can create any number of assets, even Darwin assets, something we'll be talking about in future videos. But for now, we're going to create a new asset for EURUSD for Darwinex and import this tick data that we've pulled for February 2019 into it, just to quickly demonstrate how to go ahead and do that. So we've got EURUSD .to_CSV. I'm going to save this file into a location of my choice, which will be here, the same as my directory that I used for getting the data in the first place. Let's call this EURUSD_209.201.902.CSV, and that's it. So this will save my data frame into a CSV file, and once it's done doing that, I'm going to move into Strategy Quant, where I'll create a new symbol for Darwinex tick data and import this data that's being saved to that CSV over there. So we're inside StrategyQuantX now, and what you're simply going to do here is go to the data manager. You've already got the default symbols that come with Strategy Quant, but the first thing I want to do is create myself my own symbol. And here we'll call it EURUSD_DWX. I've done this before, so it's still there from the previous run. Timestamp represents start of bar time, which is MetaTrader specific, and the instrument is $, in my case, which is data for tick data for which I'm importing into Strategy Quant. We'll leave everything here on default because those values are correct. So we have instrument $, type Forex. Tick size is 0.0001 and the size is a point. Default spread doesn't matter for us here because we can vary that later. And that's it. We create our symbol. Once we've created the symbol, we need to import the data we saved in from our data frame into a CSV file. For that, we simply go to File, Import, click on Import File, browse for the file in question. Here's the file that I saved earlier on. Double click that, and now we've got a few things to do here. So we've got our timestamps converted into human readable dates. So we'll choose date and time for that. We've got we know that ask price was the first column, bid price was the second. So we set this to ask and set this to bid. For our purposes here, we ignore the spread. So we say unused. And that's it. So we've got date time, ask and bid tick data fed into, ready to feed into Strategy Quant. Start the import process. Strategy Quant goes away and starts importing the data. And once it's done doing that, we can visualize what it looks like. So now that that's complete, we can visualize what the data looks like. Strategy Quant has inferred the time frame as tick, which is correct, and the time zone as UTC, which is also correct. We have 28 days of data since we only took February of 2019, and that's 2825072 number of ticks processed. If we just quickly take a look at what this looks like, we can't analyze data quality or view the chart because it's tick data. We just want to make sure everything's been imported correctly. You'll see this volume parameter here. This is tick volume, MetaTrader specific. Once this is converted, if you're building strategies using other timeframes, timeframes other than tick, then for M1, resampling 5, etc., so on, for any other time frame that's resampled inside Strategy Quant, Strategy Quant will correctly calculate the volume per new precision using these ticks. So you can safely ignore this for now until you get to a point where you're building strategies in Strategy Quant that involve timeframes higher than tick. And that's pretty much it. So that's a quick example of how to import Darwinex tick data into Strategy Quant's data manager. In future examples, we'll be doing how to import Darwinex tick data as an FXT file into MetaTrader for backtesting on MetaTrader. And we'll also go into a lot more detail on the FXT format since it's slightly more complex than the HST format we discussed in previous videos, as to how you can go about creating, not only creating FXT files per time frame for backtesting accurately in MetaTrader, but also other concerns, other things you need to keep in mind when doing that sort of backtesting. And that's pretty much it. So what we've covered today, once again, is where the Darwinex tick data exists. It's on our FTP service, what format it's stored in, what is the structure of the file inside, how to read that comma-separated data, then standardize it to one format. In our case, we selected this format. You are, of course, free to choose any other format that suits you or the application in question that you're working on. We talked about and showed the code for resampling and rebasing to OHLC if that's necessary. If you're not working with a tick precision data and you require other formats, the code is there in the script shown to you earlier, which will be published to GitHub after this tutorial, to go ahead and resample to whatever time frame you choose, and even rebase it if you're choosing daily as your time frame, for instance, and you'd like your hours to start at a different GMT offset and things like that. All that functionality is available in the script, so you can use it or modify it to suit your purposes. We had a little demo of importing Darwinex tick data into Strategy Quant, the data manager component, how to create an asset inside it, and how to import the tick data, how to treat the columns once you're importing the tick data, and then visualize that tick data, Darwinex tick data. In future videos, we'll talk about, as I mentioned earlier, the FXT format, how to go ahead and create FXT files out of Darwinex tick data per time frame, constraints and limitations of MetaTrader as regards your backtesting effort, and things like that. And that's it. So if you like this tutorial, please consider sharing it with your social networks, colleagues, and friends, especially friends in trading, algorithmic traders, academics, enthusiasts, data scientists, anyone who is a quant or data geek, or any algorithmic trader who would benefit from using Darwinex tick data or adding Darwinex tick data to their arsenal of tick data repositories for the best, most robust backtesting possible. Please consider sharing this with them, and of course anyone else who you think would benefit from it. Thanks for your attention. See you next time.